Hi guys, today I want to discuss Dehoff 8.8 question. So in the 8.8 question, the excess free energy of mixing is given. So here this is not alpha, this is excess term, and the excess term is given with respect to mole fraction of aluminum and zinc, and there is a temperature term. So this is a very complex solution that we are dealing with. Now we have to plot the curves for delta G mix. So this question seems very tough or very confusing at first, but we need to do this very simply. So let's try to do that. So if you see, G equals to H minus T into S. H is enthalpy, T is temperature, and S is entropy. So if you put a delta term here, delta G equals to delta H minus delta Ts, and delta G is always measured at a particular temperature. So delta G is measured at a particular temperature. So delta G is nothing but delta H minus T is constant, so T comes out into delta S. So what we do is we put delta G mix equals to delta H mix minus T delta S mix. So when you are mixing like two atoms, so there is A atoms and there is B atoms. So this is A and this is B atom. So when you are mixing, there is configurational entropy. So this configurational entropy is related to this term. So these two are the same. So the configurational entropy of mixing delta S mix equals to, here I am doing a simple thing, it looks like this. So we have this term, so the delta G mix is nothing but delta H mix minus, so this term we have a minus term here, so that we have minus T into minus of this term, so that would become delta H mix plus R, okay, so there is a R term here, RT into summation of xi ln xi. So there are two elements, so there is I goes from 1 to 2. So this term is called the delta G mix of ideal term, because for ideal solution delta H mix equals to 0, but here we should note that delta H mix equals to the excess term which is given in the question. So in the question, the term which is given here, this is equals to delta H mix. So we have both the terms, delta H mix and this term. So if we write that down, we have delta G mix equals to X aluminium X zinc into 9600 into X zinc plus RT So we need to plot this as a function of composition XAL. Let's do with XAL. So we turn the X zinc is nothing but 1 minus XAL. We will use this relation. And we have to do at a for temperature range for this temperature range. So let's do that. Provided the MATLAB code to do the plotting, and here the delta G mix is provided, and the temperature T here goes from 300 to 700 range, and I have used these parameters where X is varies from 0 to 1 and it has 100 points between 0 and 1, and I have set my image or the figure box in this size. Now what I do is I do add points, so it will add each point for each X. So this H is like the animate, this H is an animated line, and this has a color red, and this has a line width of 4. And what I do is I do add points, I do point add for each X and Y. So this is X and this is Y coordinate, and this H is the animated line which has these properties: red color, line width 4. And in the same way I do the plotting for all the others. So this for loop contains only add points and draw now command. So let's do the plotting. So the first curve is for 300 Kelvin, the second curve is for 400 Kelvin, third curve is for 500, then 600, and then 700 Kelvin. So this is how the plot looks like. If you like the content, please click on the like button and subscribe to our channel. Also, please do comment on what you like about this video. It would be helpful for me to make new and interesting videos. Thank you.